Hi everyone, and welcome back to this special episode of our conference summer. We are here in Philadelphia at the Marriott Convention Hotel, and we're at the 33rd USENIX Security Symposium. In case you don't know, USENIX Security is one of the most important conferences when it comes to security and privacy, which are two of CISPA's main research areas. We have actually met an old friend here. His name is Sebastian Roth. He did his PhD at CISPA in the research group of CISPA-Faculty Dr. Hi Sebastian, it's nice to see you again.
Yeah, always happy to see the old CISPA people at conferences.
So Sebastian, you are now a postdoc in Vienna at TU Vienna, right?
Yeah, in the security and privacy division.
Okay, so you of course kept continuing what you've done with Ben. Can you just tell us a little bit about what your research area has been and still is and will be in the future?
Yeah, well, at CISPA, that is actually a longer story because initially as a student I started as Hiwi at Sascha Fahl's group.
Okay.
And when Sascha moved to Hanover, I switched to Ben's group as student assistant. So I actually started with usable security,
okay.
Then continued with web security. And well, in the process of my PhD, after doing a bunch of measurements where we have seen that everything in the web seems to be horribly misconfigured, I remember the good old usable security days and then teamed up with Katharina's team to actually check what is the root cause of all these misconfigurations.
Okay, so you tried to basically work at the intersection of those two areas?
Yes.
So as you said, okay, the web is not particularly secure, and to change that we have to figure out why users develop it, or why developers develop the web it is.
Yeah, or how we can at least ease the process of deploying security mechanisms such that not only the big players have secure web applications, but also your small local banking application is secure.
Let's just talk about how your PhD has been at CISPA. I mean, you finished last year, I think?
Yeah, last year in April.
What did you like particularly about doing your PhD at CISPA? Is there something you can recommend to other people who might think about it, or in general, what's it like to work at CISPA, to do your PhD at CISPA?
So I think the most awesome thing was to have so many other researchers and other research areas around, because as said, I was very happy that when I detected all those misconfigurations, that Katharina's group was like few doors away, such that we can join the expertise to work on this intersection between web and usable security. And well, if there would not have been a usable security group, that would have been harder. And in general, now as a postdoc, if I'm talking with other postdocs here at conferences, I already know super many of the big heads in the security and privacy business, because well, I academically grew up at an institution with 30, 40, 50, I don't even know how many faculties.
More than 40 now.
Yeah, but with a lot of faculties that are known in the community. So that is super helpful to, well, join the community if you already know a bunch of people from the community. And Ben was always very supportive and saying, hey, by the way, this is Sebastian, I'm a PhD student. And so it was then also super easy to get to know the non-CISPA people at the community. And I think regarding getting connection to, well, all security researchers in the world, it was a super nice thing that CISPA is that big. Okay. My guess is that it would have been harder if I would have done my PhD at a smaller institution.
Yeah, okay, sure.
And well, another nice thing was the funding.
Yeah, okay.
I mean, at smaller universities, it might be harder to say I'm going to Philadelphia to connect with the community, to work on new projects, new collaboration partners. And when I ask Ben, hey, if I'm, for example, attending SOUPS, so another conference.
So it's a symposium on usable security and privacy, which is a very sharp,
which is co-located with USENIX.
Which is a very sharp focus on usability, right? Yeah. On usable security.
Yeah. And if I'm then, ask Ben, if I'm in the area anyway, can I also attend the USENIX? Then it was always, not a problem. There is funding.
Yeah, I mean, which is great because you can very early in your career get to know other people, start new.
And also attend a bunch of conferences every year. I think when I started as a PhD student in 2019, it was immediately in my first year, without having a paper there, attending DEF CON and USENIX and everything, which was super great and directly made me addicted to the academia lifestyle.
Yeah, okay. So, seeing as you're a postdoc, as you said, you're addicted to academia. You want to stay in academia after you?
Yes. So yeah, definitely. I enjoyed it very much. Still, what I think every PhD student should do is an internship to at least see the non-academic world. That was, although I very much liked it at my internship, it showed me that I very much like this freedom in academia to do what the hell I want whenever I want it, and that's why I want to stay in academia. But I mean that's a very personal thing for everyone. So other people want to have maybe a strict career path, which is not always the case in academia. So that's why I would suggest every PhD student to just do an internship to know both sides of the coin, which probably makes the decision easier then. Okay, Sebastian, but you are not just here to meet old CISPA friends, although that is a nice bonus, but you are actually here to present a paper. It is called Trust Me If You Can, How Usable is Trusted Types in Practice. And you actually started working on that while you were still at CISPA. And it was accepted at this year's USENIX. Yeah.
Please enlighten me. What is it about?
Well, also a longer story. Maybe I'm talking too much.
No, you're definitely not.
So the work that we worked before was about content security policy, also web security mechanism, but it's already widely used in the wild. More. I think probably in the meanwhile even wider, but more than 10% of the websites already protect the application or try to protect the application with the content security policy. And after doing a usability check or after we assessed roadblocks and deployment strategies and so on of content security policy, we then approached the World Wide Web Consortium, those are basically the guys that are creating the standards for the security mechanisms, and talked with them about improvements suggestions. But because it is already a widely used mechanism, it's hard up to impossible to introduce breaking changes in the standard.
Because then it would kill a lot of websites and introduce a lot of maintenance.
And then instead of saying, bad luck, then we are not continuing that research path, we thought, then we are choosing a mechanism that is not even standardized yet. It's still under discussion whether it should be standardized, and this was or is trusted types.
I think I need a little more background on what the secure content policy is.
Content security.
Content security, excuse me.
It's basically as a website operator, as a developer, in a bunch of attacks you have problems that attackers start loading malicious content from somewhere else, from their own servers. And with the content security policy, you can as a developer define, for my website, all images that are loaded need to come from myself or Facebook or
Okay.
something like that, such that the attacker cannot load fake pictures from
another server.
Yeah.
Okay.
And same, for pictures it's not as severe, but that also holds true for JavaScript, so for program code that is executed and
executed in the browser that could potentially do harm.
Yes, because it can then steal essentially the session cookies, so your logged in state, issue state-changing actions, like if you have the vulnerability on your banking website, it can issue bank transactions and so on.
Okay.
So
which you don't want.
Yeah, which we don't want, of course. And therefore you can also, as in the content security policy, define a strict allow list of which sources are allowed for JavaScript code that are loaded into the web.
Okay.
The problem is that there are certain programming patterns in the web. We could call it a design issue of CSP, because if there is dynamic code execution, in a sense that there is some program loaded that is always changing, and is then flowing into eval, which is basically an API to do string-to-code conversions, such that you can dynamically execute some code that you loaded from somewhere.
Okay, it's a little complicated, but
it's complicated. But
the gist is
in those cases, in the content security policy, you can either allow everything or nothing.
Okay.
And because those programming patterns are also used by, for example, advertisement vendors, the majority of websites then decide to allow everything because they want to make money.
So it's a granularity issue, basically.
Yes, and with trusted types, they try to fix that issue by enforcing that those dangerous APIs, like the string-to-code conversion things, can only be called with a trusted object, such that all code that flows into those functions needs to be sanitized before, such that you can detect whether there is malicious or benign code that is going to be executed.
So does that mean someone has to certify that code beforehand?
Yes, and that's the entire problem, usability problem here, because those sanitizers need to be written by the developers themselves. And it is sometimes extremely hard up to impossible to do that correctly. Which is also why it is not yet standardized, because directly after it was proposed by Google engineers, other people at GitHub Commons already raised concerns regarding complexity and engineering effort when deploying this mechanism.
So just to see if I get this right, if you want to use that new type of security feature, you basically tell your website, okay, you can only load code that has been sanitized, or let's call it checked or cleaned by a certain software, and that software needs to be written by every developer themselves.
Yes, because every website is different, so it's super hard to have a one
size fits all.
Solution.
That doesn't really work. Okay, so then that introduces basically a lot of overhead on developers.
Yes, and when you need to write a lot of code, there is a lot of possibility to make errors.
Yeah. Okay. So, but what did your paper find out? So, did you discover that it is used, but it's just not implemented very well, or do people actually say, okay, this is way too complicated?
It's not yet standardized. So the only implementation that is available is the implementation in Chromium, because as I said, Google engineers proposed it, so they already implemented it in their browser. And therefore, we were also kind of restricted to use Chromium in our study. There are, I would say, technical roadblocks that, during the standardization of the thing will probably at some point have popped up anyway, because you can at websites basically have other websites loaded into those websites in so-called iframes. And if it is a special kind of iframe, so-called same origin iframe, the content security policy is inherited to those iframes for security reasons. And trusted types, or enabling trusted types as a developer, is done via the content security policy by saying we require trusted types for script executions now. And the problem is that those sanitizers that we mentioned earlier are JavaScript code, which is not inherited. So in those iframes, there is now basically a security policy that enforces the usage of the sanitizers, but the sanitizers are not available, so everything goes boom.
Okay, so I mean, I am.
It's a complicated edge case, but
it's but the thing is, I am not a web developer, right?
Yeah.
And but still, I mean, imagining like if I were to develop a website, I have a fun new idea, I want to write some code. I said, okay, this is a great new feature, you can stream some music here or whatever. I'm not sure if a lot of developers even have that kind of deep knowledge about what makes a website secure, how do you make it secure, and then, as you say, there are so many edge cases.
It's complicated. Especially, if you are from the beginning when writing a new web application, when you are aware of those issues, it gets easier. Mm-hmm. But if you retroactively try to add them, it's super hard because you or other people in the development team might have used programming patterns, which makes it hard to actually deploy those mechanisms. Okay. At the same time, nearly all web security mechanisms, the code that you as a developer has written is not so much of a problem because that is code that you can actually change to not have this bad programming patterns anymore. Okay. However, if your advertisement vendor is using that patterns, you cannot change the code that you get from your advertisement
That's vendor. True, And a lot of websites are...
and advertisements and analytics.
It pays for the website, right?
There is basically no website without. And therefore, those third parties are usually the blocking factor for security mechanisms.
Okay. Getting back to the new type of security feature that you have discussed in your paper. You said it's very new, so you're basically working at the forefront of a very new thing.
Yeah.
Do you think it will get better? So at least that type it will get properly implemented. And,
I mean, not only the academic community but also the World Wide Web Consortium is actually heavily working on it because in December last year, Mozilla changed their standard position to positive, such that it can now become a standard.
Okay.
And they are actively working on it becoming a technical specification. And there are other features that will help in the process here. So one part is sanitizing the JavaScript code that I mentioned earlier, but another part of trusted types is sanitizing HTML. So basically the other, I wouldn't call it programming language, but the other language that is frequently used in the web. And there another web feature that's currently in the process of being widely deployed in browsers is the Web Sanitizer API, which very much eases the process of sanitizing HTML.
Okay.
There are still problems to be solved, but there are academic papers working on it. There are the people from Mozilla, Google, Microsoft working on it. So
things are moving in the right direction.
Yeah.
Okay. But I think that's a really interesting point on how many people are actually working on implementing standards to make sure that the web we use, every one of us uses it, and basically I think 99.9% take it for granted that it's just the way it is. But so many people are actually working on these standards and trying to find bugs, make it more secure, implement standards that make sure there will be no more bugs, and I think that's really interesting. It's also really interesting that you are actively working on making these standards better.
Yeah, I mean, there are the underlying issue, so cross-site scripting, this malicious code smuggling into web applications. It is there since, I think, 25 years now.
Okay.
Nearly. And although there were nice technical ideas how to solve it with proper separation of code and data on the server side, with the content security policy and so on, we are still not at the point where it is solved. And I think one reason why that is the case is up until a few years ago, those security features were created in the ivory tower of scientists or in the ivory tower of browser vendors. And they are perfectly working for example, Google.
Yeah.
But they are not working for the vast majority of websites. That is because all those mechanisms were only created by expert developers, but not for or together with the average web developer out there. And I think we are slowly starting to understand that the human part, the human factor is a core part of every technical system, also websites and web specifications and so on. So
that's where your usable security part comes in.
Exactly.
Because even if you have the perfect solution, if you don't have like a developer who understands how to implement it, you won't have it deployed on a website.
And I think if we are continuing that route in understanding developers as a core part in those security mechanisms, then I think it will be easier to arrive at the point where we have a nice technical solution that is also easy to use for everyone.
Yeah, but I don't know. Let's maybe shortly talk state of the web. I mean, you said that cross-site scripting, it has been known for quite some time.
Yeah.
And still it's not fixed. Do you think we're now better off than we have been, I don't know, 10, 15 years ago? I mean, I started using the internet.
Definitely. Not only regarding cross-site scripting, but also multiple other issues.
And maybe just on a side note, cross-site scripting basically means that someone runs code in your...
smuggles markup content like code or pictures and so on into other web applications.
Yeah.
And because they are then essentially part of the web application, this smuggled malicious code has the same capabilities as the normal code. So it can essentially access your session, issue state changing actions, and do all kind of shenanigans.
Okay. Getting back to you think we're better off than we have been 15 years ago?
Yeah, I mean, for many of the issues there are solutions, and also when we are talking about content security policy and trusted types and so on, they are not perfectly working, but at least they make the attacker's life a bit harder. But there are also other solutions for cross-site scripting. There is basically a client and a server-side part of or issue of cross-site scripting. And for the server-side part, there are many frameworks nowadays that automatically separate code and data, such that data injected by an attacker are properly encoded and separated from the actual content that is delivered, such that it's super hard for an attacker to inject that. But there are still issues on the client side, which is what the content security policy and trusted types try to tackle. But still, they make it already harder. And for some websites, especially those that don't have any dependencies on third parties, they already have a super rock solid content security policy that's basically blocking things. But those are the few websites that are not requiring any analytics, and super often those are non-profit organizations because they don't need to make money with advertisements.
Yeah, of course.
Or those are organizations that are essentially their own third party, like Google. Yeah. If they are seeing there's a shitty pattern that is blocking the deployment in our Maps API that we are loading, they are probably calling the Google Maps team and saying, change this stuff. But that of course doesn't work for smaller companies that are just using the Maps API.
Okay, so the short answer is it is getting better, but we're still working on it.
Yes. Better, but still not perfect.
I mean, we can it is debatable if there is such a thing as perfect in web security if we take in the human factor.
But there are things that has been a bigger issue 10 years ago, but are nowadays not perfect still, but have changed to be very good. Like if you When I was young, the vast majority of websites didn't have proper transport encryption. But nowadays, I have no statistics in mind about the adoption of HTTPS, but at least all websites I'm frequently using are using proper certificates.
Actually, if you're using a website in a somewhat modern browser, you will get a warning, right?
Yeah,
that it is not encrypted. It is not using HTTP.
It depends a bit on the website, but essentially yes.
Yeah. All right. Okay, so as I said, you're working on it, but of course other people are as well. That's why you're here at USENIX Security, to listen to other talks, to discuss with other people on what future collaborations might look like. Maybe enlighten us a little bit. What's a conference like for you? Like what sessions do you go to? Do you prefer listening to usable security stuff, or do you actually listen to stuff that you might not even work on yet?
That sounds a bit weird, but I'm usually not going to the web or usable security sessions, because essentially I'm usually either I might have reviewed some of the papers or I already read the pre-publications, because if there's a funky new attack technique coming up in the web community,
then you can't wait until the conference.
I cannot wait until the conference. So at the conference, I rather go to, I would say, related research areas, or research areas that I want to tackle in the future, like a mobile security session or the network security session, to get some nice ideas how I can maybe combine my knowledge about usable and web security with nice ideas from the mobile security domain to, come up with nice new paper ideas, nice new defense mechanism, or maybe new shenanigans that we can do in, for example, the mobile domain.
Yeah, okay, sounds fun. All right, then thank you so much for taking the time out of the hallway track, as we call it. So just as a heads up for our listeners, the hallway track is usually what you refer to standing around the hallway here at the conference and talking to your old colleagues or potential new colleagues, which is basically what we're doing right now.
Yeah, always a pleasure to talk about research.
Thanks, Sebastian.
And to meet old and new friends.
Yeah, same goes for us. So thank you very much. Have a great time here at the conference, and all the best for your postdoc in Vienna and whatever the future may bring.
Thanks. Thanks for having me, and
Bye-bye.
Bye.